Hello, this video is on the sum of arithmetic and geometric series. If we take the terms of our sequence and add or subtract them, we're going to get a series. So let's look at the first example, which is the arithmetic series. So here we're adding numbers and we're looking for the sum of the first 8 of these terms. So here they are 1, 2, 3, 4, 5, 6, 8, and we're looking to add them up. Yes, we can just punch them in the calculator, but if these numbers were but if we were looking for, instead of 8 terms, for the sum of the first 80 terms or 100 terms, then having the formula would be so much faster than just punching in 100 or 200 numbers in our calculator or the Excel spreadsheet. So this is where the formula for the sum of the partial sum of arithmetic series comes in. Partial means we're not adding all of them, we're just adding some of them. So the formula, where does this formula come from? I'll show you the formula in a second, but let's look at the numbers first to see if we can come up with a formula ourselves. So if we look at the first number and the last number and we add them up together, that comes out to be 9. If we look at the inside, 2 plus 7, that's also 9. 3 plus 6, that's also 9. 4 plus 5, that's also 9. So all we are doing is we're adding a bunch of 9s. How many of them are we adding? Well, we're adding them in 2s, and there is 8 numbers. So we have half of the 8, which is 4. So we have 9 times 4, which is 36. And that's the sum of the arithmetic, of this particular arithmetic series. Now, the formula for the partial sum is below. So here I'm going to scroll up a little. So here's the formula for the sum of any arithmetic series. And it says exactly what we just did. It says take how many numbers you are adding, which is 8. You're adding them in pairs, so divide that by 2, and then multiply it by the first number, which is 1, plus the last number, that's the 8th number, which is the 8, and so we have 4 times 9, which is once again 36. So this is how to add to compute the partial sum of arithmetic series. And remember that arithmetic series simply means that to get from one number to the next, we are adding or subtracting the same number. So to get from 1 to the 2, we add plus 1, plus 1, plus 1, plus 1, plus 1. That means we are looking at arithmetic series. The next two formulas deal with geometric series. Geometric series is when we multiply by the same number to get from one to the next. And so here is an example with the formula right next to it. So suppose I'm trying to add the 10 terms of this geometric series, and I've listed all the 10 of them, and this pattern continues forever. But let's say I simply wanted to compute the first 10 of them. Well, the formula is that the sum of the first 10 is the first number, that comes out to be 384, minus the ratio. The ratio tells you what number we're using to get from the previous to the next. So from the next to the previous. So if we take any numbers that are next to each other, let's say these two, and we take the next divided by the previous, that comes out to be half. And if this pattern continues for all the numbers in our series, we have geometric series. So if we take, let's say, these two numbers, 24 divided by 48, that's also a half. And the same for all the numbers in this list. So the ratio for our particular example is half. So using our formula then, we have 384 times 1 minus ratio, which is half, to the power n, and then all of it is divided by 1 minus ratio, which is again half. We just have to make sure that r is not 1. If ratio happens to be 1, Then here on the bottom we have 1 minus 1, and that's 0. So we're dividing by 0. That's impossible. That's why we have to be sure ratio is never 1. Now we just have to type in all of this in a calculator, and we should get the answer. It may be easier to type in the half as 0.5 because that would require fewer parentheses. So I'm scooting over the drawing so we can put the calculator next to it and type in the numbers. 384 times 1 minus half will put us 0.5 to the power n. N is how many terms we add in. We add in 10 terms, so our n is going to be 10. And then we have divided by, in parentheses, 1 minus half, and press enter. This is the answer, 767.25. So our answer is 767.25. And that's the end for how to compute the partial sum of a geometric series. Now, if the geometric series happens to be going down, so that the numbers are getting smaller and smaller and smaller, then we can find the sum of all of them. It's no longer partial sum, it's the sum of every single number all the way to infinity. And that formula is right below. It is called the infinite sum of geometric series. And it works only if the ratio, the absolute value of ratio, is less than 1, meaning that the numbers are decreasing in size. And if we add numbers that get smaller and smaller and smaller forever, then eventually these numbers are going to be so tiny that their contribution is so negligible that it no longer changes the sum. And that is why we can add all of them. We can compute the infinite sum, even though we're not really adding all of them, but we will get the same result. So for us, the infinite sum of the same series we just looked at is the first number, which is 384, divided by 1 minus ratio, which is half. Typing it in the calculator, we will get the answer for the infinite sum. So 384 divided by 1 minus half comes out to be 768. So we can see that after we added the first 10 terms, the answer is almost 768. It's only off by 3/4. So if we add all the numbers from 1 to forever, the only thing we're gaining more is just 0.75. So the final answer to the infinite sum of this geometric series is 768. And that's it for how to find the sum of arithmetic and geometric series. And that's it for this video. If you have any questions on anything, please let me know. Thanks a lot for your time. Take care.